Okay, so we're looking at the second of our three. Now we're going to look at dipole interactions. So these are going to occur between polar covalent molecules. So remember, polar covalent molecules have a higher difference in electronegativity. Their electrons are not being shared equally. So they're going to be between zero point 0.4 and less than 2. So keep in mind, anything that's 2 or greater is ionic bond, right? There's a transfer of an electrons. So we're in that polar covalent, so not being shared equally. One atom has a stronger pull than the other, all right? And we have a partial positive and a partial negative end. So that's what creates the dipole. Unlike the dispersion forces, this dipole isn't temporary, right? Because they're not sharing the electrons equally. So if we look at hydrogen and fluorine, they have a high difference in electronegativity, right? 1.9, almost ionic. So fluorine here is holding it together, and we do this little partial positive arrow here towards the fluorine to indicate that fluorine holds those electrons closer. It's stronger than dispersion force because the dipoles aren't temporary, okay? So what happens is we have this partial positive and partial negative. So you can look at my awesome drawing. So if this is hydrogen and fluorine, right? The green would be the hydrogen because that's the partial positive. Should be much smaller. And the purple, green is the hydrogen, purple is the fluorine, so that's the partial negative. So these molecules are going to orient themselves so that the partial positives are and partial negative ends are around each other. So this is sort of a two-dimensional view of what that would look like, but there'd be all these molecules kind of orienting themselves and kind of moving around. So we're just looking at polar covalent molecules, right? So remember, they have the dipole, they're not temporary. So if we go back to our tug of war example, so I got this guy here, and then I got this guy here. Maybe he's not this big. Maybe this would be more representative of ionic, but he's bigger, right? And they're doing the tug of war. This guy is, I don't know, say this guy's stocky, right? He's pretty strong, right? Maybe I drew him really small. So he can kind of hang on to the rope, but he's really struggling. And this guy is like keeping the rope closer to his side pretty much all the time. This guy's hanging in there. Like he's not gonna lose. Like if this was an ionic bond, this guy would be on the ground, right? He had lost. But this guy's holding his own. He's been working out. And this guy's just kind of like hanging in there. And he's always got a easier, he's maybe just like doing this with some effort. This guy's just, he's working hard. You get the idea. All right. So that's a dipole interaction. So remember, partial positive, partial negative. Dipole is there at all times, right? Looking at these molecules, this is how they're arranged. Okay.